Hi, I'm Carl, and in this video we're going to go over questions 47 to 49 of section 3 of the pink booklet. So this is a question about some property called H and how it varies with different carboxylic acids. And so we've got a table here which I've copied out, and we'll start with question 47, which says which of the following is the best estimate of the value of H for 2-chloropentanoic acid. So from this table we have some trends here. As the length of the carbon chain increases, this value of H tends to increase as well. The exception is when there's a chloro group, and particularly if there's, well, we have a couple to compare. So if we look at propanoic acid, for example, the presence of a chloro group decreases this value of H, but it depends largely on where it is. So the lowest value of H here would be for 2-chloropropanoic acid, and 3-chloropropanoic acid has a higher value of H. A better thing to look at then maybe might be butanoic acid. We've got 3 different chlorobutanoic acids to compare. And as the chlorine group gets further and further away from the acid group, this H value tends to increase. So 2-chlorobutanoic acid has a much less H value than 3-chlorobutanoic acid, and the same is true then between those and 4-chlorobutanoic acid. So if we were to look at 2-chloropentanoic acid, what would we expect? Well, we know this chloro group tends to bring it down a little bit, but we know that every time you add on a carbon, it gets a little bit higher. So let's have a look at 2-chlorobutanoic acid, which we've got here. We know that that has 4 carbon atoms in it, so if we're going to have 5, it's going to be greater than 45.6. But based on these two values, we know it's probably going to be less than those. So that narrows it down to A or B. Is it more likely to be 46.1 or 57.7? Well, for it to jump up from 2-chlorobutanoic acid here up to 57.7, that doesn't seem consistent with the increase we got when we added a carbon between these 2 points. So we saw an increase of 0.4 or so. So if we added 0.4 or so again next time, we would get 46.1, and that's sort of within the range of what we'd expect. And that's answer A then for 47. The other ones just seem too high from the values we've got in this table. 48 says which of the following is most likely to have a value of H closest to 60.7. So we've already got one that has 60.7, and that's 3-chlorobutanoic acid here. So going through the options we've got here, so 3-chloropentanoic acid actually seems fairly likely. If we compare, and I'll rub out some of these arrows just so it doesn't get confusing, but if we compare 3-chloropropanoic acid and 3-chlorobutanoic acid, we can maybe start to see what would happen if you had 3-chloropentanoic acid. So the values here are 60 and 60.7. So if we added another one, we'd expect the 3-chloropentanoic acid to have a value slightly higher than 60.7. So maybe we can just write that down. So A is going to be slightly higher. If we look at B then, it's 4-chloropentanoic acid. And we can see that 65.5 is obviously much greater. And when we add another chlorine or another carbon on, it's going to get higher still. So we can rule that out. If we look at C, then it says 4-chlorohexanoic acid. And again, that's going to be the same issue. It's going to be much higher than what we'd expect. And then D is 5-chlorohexanoic acid. So one of the things I said earlier, one of the trends that I think are clear here is that as this number on the left increases, as the distance between the carboxyl group and the chlorine group increases, this value of H tends to increase as well. And so having 5-chlorohexanoic acid, we'd expect that to have a higher H value than 4-chlorohexanoic acid. And if we've already ruled out 4-chlorohexanoic acid as being too high, then we can rule out D. And so because A is already going to be fairly close and the other ones are much higher, we can, I think, pretty confidently say the answer for this one is going to be A as well. Then if we look at 49, it says, which of the following is most likely? The value of H and then it gives a couple of comparisons. And I think maybe just the best way of going through this is going through them one by one. So A is 3-chloro-2-methyl-butanoic acid is less than that of 2-chloro-3-methyl-butanoic acid. So what's difficult here is that they have these methyl groups which they didn't have before. But I don't know if it actually really matters, because one of the trends I think that we've seen, like I've said, is that as these numbers tend to increase, you get an increase in this H value. So if we look at those numbers, those chloro groups, relative to the carboxyl group, maybe that will give us the right answer. So would a 3-chloro acid be less than a 2-chloro acid? Well, there's nothing in the table that suggests that, so we can rule A out. What about a 3-chloro acid being less than a 4-chloro acid? Well, we would expect that. We know that 4 chloros in the table are higher than 3 chloros, and generally those numbers give us a pretty good indication of what H might be. So B is correct, it seems quite likely, but it says most likely, so we'll go through and compare the other ones, and it says C. Is a 4-chloro going to be less than a 2-chloro? Again, no. And D says a 5-chloropentanoic acid is less than 3-chloro-3-methyl-butanoic acid. Again, that's going to be a 5. Is that going to be less than a 3? No, it's not. So I think the answer here is most likely to be B. So a pretty abstract question, but that was questions 47 to 49. I hope that helped.